The interaction between seawater, rocks, and minerals that is at the core of hydrothermal circulation has profound implications for the marine environment.
Most seawater will have, in 100 or 200,000 years, will have actually passed through one of these hydrothermal systems. In a hydrothermal circulation cell, you're taking normal seawater, you are drawing it down into the crustal rocks, you are reheating it to very high temperatures on the ridge axis, even very intermediate temperatures on the ridge flank, and you're exposing it to rock that has a lot of chemicals that want to react with it. There's a lot of iron. Iron is given off from the rocks into the seawater. Magnesium is absorbed from the seawater into the rocks. Calcium is given off. That's forming this chemical balance at very high temperatures. And so the fluid that actually comes out of a hydrothermal vent is chemically much different than the fluid that went in, the seawater that went in. So it is changing its chemistry.
Some of the chemicals that are in high concentrations in this hydrothermal fluid are hydrogen sulfide, and that's one of the chemicals that's very important for the life that exists at hydrothermal vents. The hydrogen sulfide is an energy source, so it's comparable to sunlight. Plants on the surface of the earth use sunlight as an energy source to create compounds, and the microbes and bacteria that live at hydrothermal vents use hydrogen sulfide as an energy source to build carbohydrates. And these bacteria at hydrothermal vents are the base of the food web there.
What is perhaps most spectacular about hydrothermal vents are the exceptionally strange organisms that have somehow adapted to and apparently thrive in this unique region of the deep ocean.
By some estimates in hydrothermal vents, there are hundreds of species that are unique to vents, not found anywhere else on planet Earth. Hydrothermal vent tube worms are an example, lots of arthropods, just a very large number of species that are unique to these vent sites. What is particularly interesting is to look at the evolution of these life forms, to see where do they come from. Do they evolve there? Do they evolve somewhere else and then migrate there in evolutionary time? Those are some of the interesting questions in the evolutionary biology of animal life forms at vents at the moment.
For many scientists, the lure of hydrothermal vents extends beyond the vent region itself.
I think the reasons that hydrothermal vents are of such interest is that they embody a lot of the processes that make our planet what it is. The other reason is that there's interest through NASA in the sense that if we want to look for other places in our solar system where life can exist, maybe microbial life, then what we'd like to know is how does life develop on a planet? What processes physically sustain life? And so by looking at the volcanoes and the life that they support here on our own planet, perhaps we can gain guidance to search for life on other planets as well.